Problem number 13, we've got a key that falls from a bridge that's 45 meters tall. It lands in a boat that began 12 meters away from the moment that the key fell into the boat under the bridge. The problem is then asking, what is the velocity of that boat as it moves with a constant velocity that whole time? So this problem is one that we can break it into two parts. One, the horizontal constant velocity of the boat, which I'll do in red, and the other is the vertical motion in free fall of the key falling from the bridge down into the boat. Now, we know that the change of position, because the problem told us that the boat was 12 meters away. That's not that big a deal. But the problem is we're asking to find the velocity of that boat, and we don't have the time. The time can be determined in any type of linked problem like this based on how long it takes the object to reach known heights or positions. So if I break down my variables that I know for the key, the ones that are going to be important to us, we're going to need to solve for the time, how long this took to occur. Gravity is always our negative 9.8 meters per second squared. Final velocity, the moment before the key hits the boat, I don't know, in this case don't really care about. It starts, like any object that's being dropped, with a velocity of 0, and the change of position, it dropped to 45 meters. Now, as long as I'm using negative 9.8, I should also use negative 45 meters, because then the direction, the acceleration, are in the same direction for this falling object. So with this in mind, I need to solve for time, and I have these variables. I use the equation that doesn't care or use the final y velocity, so it allows me to use this equation from my selection, solve for the change in height or change in y. I then substitute in all my numbers, because that goes to 0. I just get to do this. I do some algebra here, simplify things down. I multiply those two to there. I then divide both sides by the negative 4.9, and then I get negative 45, negative 4.9, and I take the square root of that to find the time. So second square root, 45 divided by 4.9, and I get a time of 3.03 seconds. What's nice about that time goes here. It also is the same amount of time that the boat was traveling, which then makes our final part of this wicked easy. Right, Finn?
Mm-hmm.
Super easy. We just need to know how long it took the boat to cross the 12 meters, because that was a constant velocity. We just use that change of position, that change of time, and then we get 12 divided by second. Then we get 3.96 meters per second is the average velocity of this boat as it moves when the key is dropped from 45 meters above.